In this video, if you're going for exceeding, we're going to have to get into some weeds. And here we go. Let's just jump right into it. So first of all, let's take a look up here at the equation y equals a sine x bx plus c. We're actually going to remove this d because it's going to get complicated enough. We don't need that. Next, what I'm going to do is I'm going to actually repeat the equation, but I'm going to modify it in some way. I'll show you. I'm going to take the expression a sine bx plus c, and I'm going to add to it just a replica of itself as many times as I had individual frequencies in my last sound. Next, what I'm going to do is I'm going to put in multiples. So the first multiple is a harmonic multiple. So if you have a second harmonic, you would just take this B on the second one and put a 2. But if you skip the second harmonic, you would put a 3 if you just had a third harmonic or whatever. So go ahead and put in 2, 3, 4, as many as harmonics you have, skipping the ones that aren't there. I'll do that now. If your phase shifting effect is a delay or a reverb that takes the entire effect and delays it equally, then you'll also want to put this number in front of the C. So if it says 2B, it should also say 2C. However, if you're using a phase shifting effect, you can go ahead and leave the C's alone. So what you're going to do next is for each one of those harmonics, you're going to input the amplitude from your last equation that we did in the last video. So whatever decimal number that you came up with for the amplitude of the second harmonic or the third harmonic, that's what you're going to input in front of the A. So if I had my second harmonic was 0.5, I'd put 0.5A in front of that second harmonic. And I know it's the second harmonic because it says 2B. If you did a sawtooth or a square wave or a triangle wave, you're going to want to input those individual sine waves rather than using the summation notation used in the meeting level example. This way, when we do any sort of shifting, we can do it to the wave as a complex whole. Next, you can apply effects like we did at the meeting level. You can apply effects to the amplitude, for example, 1 times sine and 0.1x. You can then take a look at this effect as it gets quieter and louder over time. The one I want to actually focus on is the unique one, what happens in a phase shifting effect when there's multiple frequencies. So here I'm going to go ahead and input a phase shifting effect of shifting backwards and forward in time, and I'm going to go ahead and use sine here, and I'll use 0.1 to show that it's shifting a little bit slower backwards and forwards. What you're going to see as we zoom out here is that this amount of phase shift doesn't just change the relative distance between peaks and valleys, it changes the entire complexity of what the waveform looks like. So as you look here, you can see each waveform has some relative similarities, but is actually changing its shape as it moves along. And that's because some frequencies are shifting a little bit while others are shifting more, and when they add together, they're adding together in different ways, leading to different levels of peaks. And so this phase shifting effect is causing more interaction than just a phase shift. There's all this pitch and volume, and that's what makes a phase shift sound so interesting. Now, if you're really looking to take it next level, some effects actually add in the original sound. So like a delay has the original sound and the echoed sound, and the phaser has the original sound and the phase shifted sound. So to do that, what you would need to do is go up here, copy this, and then actually add it back again. But when you add it back again, you want to take away anything that's creating that effect. So in this case, since this is a phase shifter, I'm just going to take away all the C's in the added one. Let's talk about the fact that a note actually doesn't just stay the same volume the whole time. Usually it comes on quickly and decays slowly. And sometimes it can do the opposite. It can come on slowly and decay quickly. And so we want to be able to model that. And if you're going for exceeding, this is sort of the last bar to clear. How do we get a note to start out loud and decay? Or how do we have a note that might come in more slowly? How do we do that in this graph? Okay, so what I'm going to do here is I'm going to actually take this entire equation and put it in a parentheses. And I'm going to take that entire parentheses and I'm going to multiply it by another coefficient. In this case, I'm just going to call it V for volume. And I'm going to add a slider. And so what I want to do with this volume is to emulate my note. Say it's a guitar string which starts really loud and then gradually decreases in volume. And so I want to have some sort of V that starts actually higher and then comes down lower. There are a bunch of equations that can do this, and I can help you through that, but I'm going to use a exponential where I'm dividing by that exponential. So over time, this volume decreases, and if I kind of ignore this stuff over here and just look at the time once we get to 0, it starts out louder and gets quieter over time. That might seem a little too extreme, so I'm going to maybe even pull that out a little bit. And so here we go. Yeah, it starts out louder, and as I'm going to zoom out here, it's going to get quieter and quieter as it sustains. So that's one example. Maybe I wanted to go the opposite way. Maybe I wanted to ramp up. Maybe I do something like this, like 0.02x. And so you can see over time this thing getting bigger. Now notice how I'm using some pretty small decimals. That's because it takes 343 meters here to just model 1 second. So if I use bigger numbers, say like I just used 2x, the volume here would ramp up so ridiculously fast that it really doesn't model anything of it actually here. If you really want to get into it, I can show you ways of making it where it even comes in, gets loud, and then fades out. I can walk you through this during my office hours, 9 a.m. to 11 a.m. every Tuesday, or through the live webinar. We've got some time. Seniors, your due date is June 2nd, which is next Tuesday, but juniors and sophomores and freshmen, you got until June 9th.